You ever use an app and it's just unbelievably fast while another one just lags? Well, today we're opening up the architect's playbook. We're going to uncover the real secrets behind building those high-performing, super scalable, and just plain lightning-fast applications on AWS. We're really going to dig into the how, so you can take these ideas and run with them.
It's the big question, right? And it's one that's probably frustrated all of us at some point. But here's the thing. The answer isn't some secret setting or a magic button you push. High performance is a direct result of smart, intentional choices you make in your architecture, right from day one. It's all about building for speed from the ground up, not trying to bolt it on as an afterthought.
All right, here's our game plan. We're going to start with delivering data at speed. Then we'll jump into scaling your compute. After that, we'll tackle what is often the biggest performance killer, the data layer. And finally, we'll wrap it all up with the architect's mindset. Let's dive in. Okay, so part one, delivering data at speed. We're starting right at the edge, literally where your users are. This first step is all about one thing, shrinking the physical distance your data has to travel. Because when it comes to user experience, every single millisecond counts.
So picture this, a huge, highly anticipated game update just dropped. You've got millions of players all hammering the download button at the exact same time. If that download is slow, it just kills all the excitement. So the question is, how do you get these massive files to a global audience without that dreaded lag?
The secret here is actually pretty simple. It's just physics. The common mistake, which you can see on the left, is trying to serve everything from one central server. I mean, think about it. A user in Tokyo pulling data from a server in Ohio? That's a recipe for a slow, frustrating experience. The high-performance pattern, on the right, is to flip that idea on its head. Bring the data to them by caching it at the edge, as close as you can possibly get. And that is exactly where Amazon CloudFront comes into play. It's a content delivery network, or CDN, and what it does is it makes copies of your files and strategically places them in what are called edge locations all over the world. So now, our gamer in Tokyo, they're downloading from a server that's right there in their region, not one halfway across the globe. The difference in speed is absolutely dramatic.
Okay, let's switch gears to a totally different problem. What if you need to move terabytes of data between your own data center in AWS? Maybe for a huge daily backup or a massive data analysis job. Trying to do that over the public internet, well, it's unpredictable. It's kind of like taking winding, bumpy back roads instead of a direct, multi-lane highway. You just never know what traffic you're going to hit.
The solution is to build that private highway. And that's what AWS Direct Connect is. It gives you a dedicated, private, physical link from your facility straight into the AWS network. It completely bypasses the chaos of the public internet, which means you get consistent, high-speed performance. We're talking up to 100 gigabits per second. For high-performance hybrid cloud, this is the gold standard.
So we've sorted out data delivery. Now let's move inward to the engine room of our application, the compute layer. This is where your code actually runs, where all the requests get processed, where the real thinking happens. Now here's a scenario that gives developers nightmares. You launch a killer marketing campaign, or maybe a flash sale goes viral, and suddenly your traffic spikes by 10 times, maybe 100 times. If your servers can't keep up, your application just grinds to a halt. You lose customers, you lose money. So how do you build an app that can handle those sudden surges gracefully?
The answer is to scale horizontally. Instead of trying to guess how many servers you'll need, you just set a performance target. For example, you can tell AWS Autoscaling, hey, keep the average CPU usage across all my servers at around 60%. And that's it. Autoscaling monitors everything and automatically adds or removes servers to meet that target. It's an incredibly powerful way to match your capacity to real-time demand. No manual intervention needed. And just like you wouldn't use a wrench to hammer a nail, you shouldn't take a one-size-fits-all approach to your servers. AWS gives you specialized instance families for different kinds of jobs. If you've got a task that needs a ton of raw processing power, like a complex scientific simulation, you'd grab a C-series instance. But for something like an in-memory database that needs to hold a boatload of data in RAM, an R-series instance is absolutely the right tool for the job.
Now let's get a little more modern and talk about containers. They are fantastic for packaging and deploying your app, right? But you're still stuck managing the servers underneath. You've still got to patch the operating system, you have to scale the fleet, all that operational busy work. And that's all time you're not spending building cool new features for your customers.
This is where a service like AWS Fargate is a total game changer. It's a serverless compute engine for containers.
And serverless just means you don't have to think about servers anymore. You just define your application and Fargate runs it. It takes care of all that undifferentiated heavy lifting. All the necessary chores that don't actually add unique value to your business, so you can focus on what really matters, your code.
All right, we've arrived at what is very often the #1 source of performance headaches in any application, the data layer. It really doesn't matter how fast your network is or how powerful your compute is. If your database is slow, your entire application will feel slow, period.
This is such a classic problem for successful apps. You get more users, which is great, but that means the number of read requests hitting your database just skyrockets. Eventually, the database just can't keep up, and the whole site slows to a crawl. So how do you scale for that massive read traffic without a complete meltdown?
The solution is a pattern called read replicas. And with a service like Amazon Aurora, you can create up to 15 of them. That's right, 15 copies of your database, all dedicated to handling those read requests. This takes an enormous amount of pressure off your main database and lets you scale out for those read-heavy workloads with incredible ease.
But what about data you need to access almost instantly? Think about things like a user's shopping cart or their logging session information. For those things, you need sub-millisecond latency. A traditional database that has to read from a physical disk just isn't fast enough. It can't keep up. See, to get that kind of speed, you have to move your data from disk into memory. And that's what Amazon ElastiCache for Redis is. It's an in-memory data store, meaning it operates entirely in super fast RAM. We're talking orders of magnitude faster than reading from a disk. This makes it the perfect solution for things like session management or caching the results of common database queries.
This all leads to a really fundamental decision every architect has to make: relational or NoSQL. For data that has complex relationships and where you need absolute, rock-solid consistency, a relational database like Aurora is the way to go. But for applications that need to scale to incredible levels and deliver consistent, single-digit millisecond performance, a NoSQL database like DynamoDB is often the superior choice, even if it means rethinking how you model your data.
Wow, we have covered a lot of ground, from the network edge, through the compute layer, and deep into the data layer. But if you look closely, what are the common themes? What are the threads that run through all of these high-performance patterns? Let's just zoom out for a second and look at the core principles, the architect's mindset.
When you boil it all down, these are the key takeaways. First, cache your data at every possible opportunity. Decouple your components so they can scale independently. Always choose the right specialized tool for the specialized job. Scale out, not just up. And whenever you can, use managed services to let AWS handle the heavy lifting. These principles are really the foundation of any great high-performance architecture. And if there's one thing you remember from all of this, let it be this: high performance is not an afterthought. It is not a feature you can just sprinkle on at the end of a project. It is the direct result of 1,000 conscious choices you make right from the very beginning. Every decision is a thread in the fabric of your application's performance. So we've walked through some of the most important plays from the architect's playbook, but honestly, this is just the beginning. Now it's your turn to take these patterns, these ideas, and go build something amazing. So what high-performance system will you create next? Thanks for tuning in.